Welcome to calculus. You will master complex problems, but forget how to add. On this episode, Stevenson will demonstrate we've talked about discontinuity and continuities. So if we have a picture, we can kind of figure it out pretty quickly. But chances are you're not going to have a picture. So how do we now determine if a function is continuous at a given point if we're given the function itself in algebraic forms? So I would like to demonstrate that for you. And I have two examples here for you. So in the first one, it says determine if f of x, and here's this piecewise function, is continuous at x equals 3. So remember, in order for something to be continuous, right, the limit has to exist and it has to be equal to the function evaluated there. Okay, so the first step is always to determine if the function exists. Now, I'm telling you to check at 3. So what we're going to do is we're going to check the limit of both sides. We want to check the left side, or the left-hand limit and the right-hand limit. So if I want to take the limit of f of x as x approaches 3 from the left, I need numbers that are smaller or left of 3. So that's going to be this piece right here. So this means I can evaluate, remember our limit properties from beginning of this chapter, we can plug 3 directly in and we get 4. Now, what is the limit of f of x as x approaches 3 from the right? Now, the right-hand side of 3 would be numbers bigger than 3, so that would be this piece right here. So notice the left-hand limit and the right-hand limit agree. So we're going to say that the limit as x approaches 3, or the two-sided limit, exists and it equals 4. So step 1 is done. We have shown the limit exists. Now, just because the limit exists, do not assume it's continuous. The second element here is the function evaluated at my c value must be exactly the same as the limit as x approaches that c value. So what is my c value? It's asking for x equals 3. So over here, what is f of 3? Well, according to my piecewise, I need the piece where 3 actually is allowed on it. X equals 3 on this one. So we can see it's this piece right here. So f of 3 is 3 plus 1, which is 4. They are the same. So let's write our sentence. We could say, well, let's use our, determine if f is continuous. So we're going to say f of x is continuous at x equals 3 since. Now, here's the beauty of this. Do not write some crazy paragraph. This is your key answer. We're going to say, since the limit as x approaches 3, excuse me, of f of x equals f at 3. Done. End of story. That's it. So we're answering the question. We're saying we're using its frame. F of x is continuous at x equals 3 since, and then this is the powerful statement I want to see. If you do not have this language written down, this is 0 points. Determine if g of x is continuous at x equals 1. Okay, what is the first step? First step is to find the one-sided limits. So we're going to approach 1. And by the way, it doesn't matter which one you start with. You can do left hand, right hand. It does not matter. So we're going to do, we'll just go from the left again. So I can see if I'm approaching 1 from the left on the number line, I need numbers less than 1. So that would be this piece right here. And because this is a polynomial, I can just plug that in. I wonder if that's factorable. This might make it easier. X minus 5, x plus 2 over x plus 2. Oh, look at that. It simplifies. So this right here is really just x plus 5. So this is just 1, or x minus 5, excuse me. This is 1 minus 5, which is negative 4. Now, if I hadn't seen that simplification, I could have plugged 1 in anyways, because you see the denominator here, it's not going to give me any sort of issues, so I could just done that. But I always like to simplify first to make my arithmetic easier. You don't have to do that. Let's check the other side. I'm approaching 1 from the right on the number line. That means I must be greater than 1. This is greater than 1, so I'm going to use this piece right here. All right, cool. The limit exists, the two-sided, so we're going to say the limit as x approaches 1 of f of x equals negative 4. Awesome. That's step 1. So what's step 2? Step 2, probably should have wrote on the other one, is to check the function evaluated at my number. So what is why am I writing f? What is g of 1? So let's look at our piecewise. So when does it equal 1? Well, when it equals 1, it tells me it's 7. All right, now let's check. Is the limit the same as the function evaluated there? No, it is not. So is this continuous? Answer, no. So how do we frame it? We're going to say g of x is not continuous at x equals 1 since, now why did it fail? Did it fail because the limit did not exist? No. Did it fail because it doesn't have a value, or it doesn't exist at 1? No. It failed because the limit did not equal the function evaluated there. So we're going to say that. So we're going to say the limit of g of x as x approaches 1 does not equal g evaluated at 1. And here's another example on how you can be assessed on continuity. In the previous problem I just showed you, you were trying to prove or check, or let me rephrase, determine if something is or is not continuous at a point. Look at this problem here. It says find a value for a so that the function f of x is continuous. So it's asking you basically to make it continuous. Kind of like the whole removable discontinuity, right? So reassign or figure out what has to go here in order to make it continuous. Well, remember, in order for something to be continuous, the limit of the function as x approaches your particular value, we call that c, must equal the function evaluated there. So what we're going to do is we're going to check the two-sided limits here, okay? Or the one-sided limits and make sure it works. So what's the limit as x approaches 3 of f of x from the left? Okay, now how did I know it was 3? Well, because 3 is the value in which my piecewise is broken up by. Okay, so 3 from the left means I need numbers less than 3, so that's this one right here. So that would be 3 squared minus 1. 9, that's 9 minus 1, which is 8. Now, let's do the limit from the right. So I need numbers bigger than 3, so that's here. So that's 2a. A is what we're solving for. Do not substitute anything in. X is 3, so that's 6a. What do we need to be true with these two limits for this to be continuous? We need these to be equal. So we need 8 equal to 6a. If I divide that, that's 8 over 6, or 4/3. Okay.